Hi there, it's Miss Wei here. I'm going to cover 17A in this video. Firstly, let's start with the starter questions. I'm going to give you 2 minutes to work on these questions, so pause the video and come back once you have finished. All right, welcome back. Let's look at this question together. A sales representative for a tire manufacturer claims that the company's steel-belted radial tires last at least 55,000 kilometers. A tire dealer decided to check this claim by testing 8 of the tires. If 75% or more of the 8 tires he tests last at least 55,000 kilometers, he will purchase tires from the sales representative. If in fact 90% of the steel-belted radius produced by the manufacturer lasts at least 55,000 kilometers, what is the probability that the tire dealers will purchase tires from the sales representative? All right, let's look at these questions. When you read the questions, sounds like this is a binomial kind of binomial distribution types of questions. How do we know? Firstly, we talk about testing 8 numbers of tires, testing 8 of the tires. So here n is equal to 8. And it says here that 90% of the steel-belted radial tire produced by the manufacturer lasts at least 55,000 kilometers. So that is P, which is probability of success, 0.9. And what we're looking for here is we are looking for 75% or more of the 8 tires. So what is 75% of the 8 tires? 75% of 8 is 6. So we're interested in 6 or more. So we are looking for the probability that x greater or equal to 6. So let's write down what we know. X is the number of tires that pass the test, and n number of trials, which is equal to 8. P is 0.9. So the probability x greater or equal to 6, 75% of 8 is 6. So used binom CDF, lower number 6, largest number 8, n is 8, and p is 0.9, which gives us 0.9619 to 4 decimal places. This question is not stated how many decimal places. Obviously, in exam, it will be very clear. It will not be ambiguous. So I assume that it is 4 decimal places. All right, we finished the starter, and let's continue on next slide on chapter 17A. All right, let's begin chapter 17A. 17A is regarding populations and samples. So this chapter 17 is about statistics, sample statistics. And firstly, let's understand what's populations and what is a sample. First, let's define populations. The populations is all the members, it says here, all the members of a group we are interested in. So the population could be all the people in Australia, depending on what we are interested in. If let's say you are interested in the spending habits of the Australians, so your populations could be all the people in Australia. The population could be all the students at Northall High School, if you're interested in the spending habits of the young people at Northall High School. A sample is basically a subset of a population. So it's taken from the population. It's a small group that's taken from the population. So you would take a sample if you're worried about how much it might cost to survey the whole population. Usually it is very costly. The bigger the populations, the more cost involved because it involves time. So if we choose our samples carefully, we can actually use the sample to make predictions about the populations. Okay, let's formally define populations and sample. So a population is a set of all eligible members of a group which we intend to study, and a sample is a subset of the population which we select in order to make inferences about the populations. Generalizing from the sample to the population will not be useful unless the sample it is a true representative of the populations. All right, let's look at examples of samples. So let's return to the NOSO students example. And suppose that Mr. Page wants to find out what NOSO students think about a particular issue. And because Year 9 students are not as fully involved in and stressed about VCE as other students, he chooses 20 Year 9 students to survey. Is this a good sample? What do you think? Well, no. Year 9 students have a different set of priorities to the senior students and will most likely have different opinions to other students. So by you only interviewing, or by Mr. Page only interviewing Year 9 students, the survey will be biased. So conclusions, how to select a sample becomes an important issue. Can you think of other samples which may not represent the populations? Firstly, let's define what is a simple random sample. So when you're talking about sample, random sample is definitely has involved probability. That means that every members in the population has equal chance of being selected. So a sample of size n is called a simple random sample if it is selected from the population in such a way that every subset of size n has equal chance. The keyword here is equal chance of being chosen as a sample. In a particular, every member of the population must have equal chance of being included in the sample. So let's look at the first example. A researcher wishes to evaluate how well the local library is catering to the needs of a town's residents. To do this, she hands out a questionnaire to each person entering the library over the course of a week. Will this method result in a random sample? All right. What do you think? Do you think it will be a good representative of the populations? Well, some of you say maybe. Some of you say no, not necessarily. Now, what do you think? Is it a fair? Do you think is that will that give a good opinion regarding to the library from the local? Obviously not, because people that come to the library is obviously, do not mind the library facility or quite like the facility in the library. So the best way to get a good sample is to go to the town. So since the members of the sample are already using the library, they are possibly very happy with the services available. Additional valuable information might well be obtained by finding out the opinion of those who do not use the library. So a better sample would be obtained by selecting at random from the town's entire population. So the sample contains both people who use the library and also people who do not. Okay, so in order for us to make a valid conclusions about population from sample, we like the sample chosen to be representative of the population as a whole. This means that all the different subgroups present in the population appear in the sample in similar proportions as they do in the populations. All right, next we want to learn how to use CAS calculator to generate random numbers. So go to keyboard, catalog, and then scroll across to obtain R. There's R here. So to generate a random number between 0 and 1, you choose R&D, rand, with a bracket, and then you press execute, which is here, and here we go. So the random number here will be 7, 3, 2, 7, 8, 4, 3, 2, 6, 3, 4. You can also generate 3 random integers between 1 and 6. Let's say you want 3 random integers and you want the number between 1 and 6 inclusive. So you can go rand 1, 6. So we got the first one is 5, followed by 2, and then followed by 4. Now, what else can we do with our CAS calculator? We can generate a list of 10 random numbers between 0 and 1. Same thing in catalog. This time you select random list, which is here, and you type 10, and so you're going to have 10 digits here. Okay, and of course you type execute, tab to view all the numbers. If you want to generate a list of 20 random integers between 1 to 30 inclusive, so you go rand list 20, 1 to 1, 30, and you're going to get numbers from 1 to 30 and 20 of them here. So type 20, 1, 30, tap execute, tap to view all the integers. All right, that's for people who are using TI Inspire. Have a look at it yourself. I'm going to leave this PowerPoint in your, what do you call that, OneNote. Okay, example. Look at this example. In a random sample generator to select a group of 6 students from the following class. So here we have how many students here? 1, 2, 3, 4, 5. So it's 20. 4 times 5 is 20 people. And I want to choose 6 people. So what I'm going to do is that we could use random number to help us to pick random sample rather than, just pick anyone like Denise, Shireen, and so on. I can use random sample to help me. So firstly, I number them. I number the students. You can number the students from 1, 2, 3 until 20. Each one of them, allocate a number to each member, assign a number, and then we use the random generator to help us to pick a number from 1 to 20. So we got number 4 being chosen, number 19, number 9, number 2, number 13, number 14. So number 4 is, who is number 4? Number 4 is Sue. Number 19, which is Georgia. Number 9, who is number 9? Number 9 is Milo. And then you have Matthew. Number 13, who is number 13? Tom. And number 14 is David. So we got all these numbers being chosen, 6 of them. Okay, next, the sample proportions as a random variable. Suppose that our population of interest is the class of students from previous example. And suppose further that we are particularly interested in the proportions of female students in the class. This is called the population proportions and is generally denoted by P. The population proportion P is constant for a particular populations. How do we work out population proportions? Which is equal to the number in population with attributes, which is in our case female, divided by the population size, which is the size of the class, which is 20. So the population proportions P, in our case, is 10 out of 20, which is half. Now remember, we also collect a sample of 6 students. Sue, Georgia, Miller, Matt, Tom, David were chosen. So now we're interested in sample proportions, P hat. So P hat is equal to the number in the sample with attribute divided by the sample size. So in our case, there are 2 female out of 6. So it's 2 out of 6, which is 1/3. So the P hat is equal to 2 female out of 6 people. 2 out of 6 is 1/3. So the population proportion P is the proportion of individuals in the entire population possessing a particular attribute and is constant. How about the sample proportion? The sample proportion P hat is the proportion of the individual in a particular sample possessing the attribute and varies from sample to sample. So the sample proportions, which is small p hat, are the value of a random variable, capital P hat. So look at the notations. Random variable is always represented by capital P hat. Small p hat is a sample proportions, just like you have done in other chapters where we take capital X as a random variable, small x other values. So in this case, capital P hat is our random variable, and a small p hat is a sample proportions. So choosing the sample in appropriate manner is critical in order to obtain usable result. Earlier, so in this particular case, p hat is 1/3. We know that it was Sue and Georgia, so 2 out of 6. And we know that it's not the same as the population proportions because population proportion is p equal to half. Is this a problem? The answer is no. In fact, each time a sample is selected, the number of female in the sample will vary. So if you select a sample of 6, another sample of 6, you might have 3 female out of 6 people in that sample. Or you can have 4 female out of 6 people in a sample. So basically, the p hat now becomes random variables. So since p hats vary according to the contents of the random sample, we can consider sample proportions p hat as being the value of a random variable, which we will denote by p hat. Okay, let's look at example 3. Use a random number generator to select number group of 6 students from the same class and determine the proportion of female in the sample. So first thing, as we have done before, we assign number to each student, and you use the random variable generator, generate, and this number appeared: 19, 3, 11, 9, 15, and 1. So the sample chosen is therefore number 19 will be Georgia, number 3, Teresa, Anne, Miller, Sally, and Denise. From this sample, we notice that there are 5 female. So I think the only male will be Miller. So 5 out of 6. So the p hat here is 5 out of 6 in this case. So summary. The population proportion P is what we call the population parameter. Its value is constant, and the sample proportion p hat is a sample statistic. Its value is not constant. It varies from sample to sample. So you can go ahead to do 17A. Like as I said, 17A is a lot of talking. It's basically just get you to understand what's p hat and what is p, and how do you get a random sample. And that's all for 17A. I'm going to get you to also listen to 17B next.